Hello. Hello.
ইয়েস স্যার, শোনা যাচ্ছে? তোমার রেকর্ডিং হচ্ছে?
হ্যাঁ মনে হয়।
হ্যালো।
হ্যাঁ চালিয়ে দিয়েছি, দেখে হলে হবে এখন। দেখতে হবে।
ওই যা যা করার সমস্ত করে দিয়েছিল তো, ওই হ্যান্ড রেকর্ডিং, টাইম রেকর্ডিং, ডিসপ্লে ক্যাপচার।
ও তো হয়েই থাকে।
আচ্ছা।
লাস্ট কি করবো? ওকে, today we'll start with an observation. Suppose suppose phi r to s be a ring homomorphism and J subset of S be an ideal, then there exists this induce and then this induce of phi induce is an injective ring homomorphism phi bar r mod j contraction to s mod j such that the diagram right, 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 diagram is commutative. So what is this? X plus j contraction goes to phi x plus j. So this is my phi bar, phi bar. What happened? What is happening here? I think phi phi bar. This is phi bar. Okay. So need to show this is well defined only. Ring homomorphism is obvious. uh, let well definedness of fiber. Note that x plus j contraction equals to y plus j contraction implies x minus y j contraction. This implies phi x minus y belongs to j. J contraction means phi inverse j. That means phi x minus phi y j, and this implies phi x plus j phi y plus j. So this is well defined. Injectiveness, let x plus j contraction belongs to kernel phi. Check that fiber is a ring homomorphism. This is well defined as now you check that it is a ring homomorphism. Belongs to kernel phi, that means phi of bar x plus j contraction equals to 0 plus j. That means phi x, it is defined by that way, phi x plus j equals to 0 plus j. That means phi x belongs to j. That means x belongs to j contraction. That means x plus j contraction equals to 0 plus j contraction. So it is injective. Fiber is injective. So this is one of my observation. And next I will say that Chinese remainder theorem. Chinese remainder theorem, it has many application. Uh, you know that what is primary decomposition theorem in linear algebra? Hello.
No, sir. In Hill, um,
I think most of them do not know it because I mean,
in
uh,
invariant case,
the
There
main.
is a prime decomposition theorem. Is it?
I mean, prime decomposition. What primary decomposition theory? I mean, those in the MSc, those in MSc, they know it. I think because I did it in the linear algebra class. I discussed it once. But those who are joining for MMath, so most of them are in their final year of BSc. So the primary decomposition is out of the scope of BSc actually. It is usually in MSc. I mean, in under usual syllabus.
Okay.
অভিরুদ্ধা বলছি ইনভ্যারিয়েন্স স্পেসে নাকি না অন্য কোথাও?
প্রাইমারি ডিকম্পোজিশন একটাই আছে, ইনভ্যারিয়েন্ট স্পেস আবার হ্যাঁ মানে ইনভ্যারিয়েন্ট ওই চ্যাপ্টারটাই
ওই
চ্যাপ্টার
মিনিমাল পলিনোমিয়ালের
হুম 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 হুম।
ইয়েটা
Chinese remainder theorem. Co-maximal condition. At first observation. Let I j the ideas of R, then the kernel of the ring homomorphism theta j is I intersection j. Proof. Check that theta is a ring homomorphism. Next, if x belongs to I intersection j, this implies x plus I equals to 0 plus I in R mod I, and x plus j equals to 0 plus j R mod j. Therefore, theta x equals to 0 plus I j. This implies x belongs to kernel theta. Conversely, if we do the arrow in this side, then done. If x belongs to kernel theta, theta x equals to 0 plus I, 0 plus j. This implies x plus I equals to 0 plus, I should write one line here. What is theta x? X plus I, x plus j, and that is equals to 0 plus I, 0 plus j. This implies x belongs to I and x belongs to j. Okay, because 0 plus I, this implies x belongs to I intersection j. So kernel theta I intersection j. Next observation, is, I don't know what is happening. Observation, if 1 belongs to I plus j, then I intersection j equals to ij, and theta is surjective. Obviously, you know that proof. Let 1 equals to x plus y, where x belongs to I and y belongs to j. Let it is it is always ij is subset of I intersection j, it is always true. Let A belongs to I intersection j. We can write A equals to A into 1, that is A x plus y, and that belongs to ij, because ax equals to ax plus ay, because ax belongs to ij, a belongs to I, sorry, a belongs to j, x belongs to I, and a belongs to I, y belongs to j, so it is belongs to ij. Therefore I intersection j equals to ij, because we know that ij is subset of I intersection j, it is always true. Now this condition is called co-maximal condition. Co-maximal condition is giving you that I intersection j is subset of ij. Now why it is surjective? Why theta is surjective? Let second part. Suppose a plus I, b plus j belongs to R mod I cross R mod j. Take, let z equals to ay plus bx. Then z minus a, what is z minus a? A y minus 1 plus bx, but y minus 1 is, what is y minus 1? Y minus 1 is minus x. That belongs to I, as 1 equals to x plus y. X belongs to I, y belongs to j. This implies z minus a belongs to I. This implies z plus I equals to a plus I. This is from quotient ring. Similarly, z minus b, what is this? Z minus b, ax plus b, sorry, ay b x minus 1, this is minus y. That belongs to j, as same logic. That means z plus j equals to b plus j. So theta z equals to z plus I j, that is equals to a plus I b plus j. This implies theta is surjective. Now Chinese remainder theorem, and this is not true. From these two observations we can say that from From these two observations, you can say the Chinese remainder theorem. What is this? Suppose let I j subset of R be ideas with 1 belongs to I plus j. Then R mod ij isomorphic to R mod I, R mod j. Proof is done. Consider theta x plus I x plus j. Then kernel theta equals to I intersection j. Since 1 belongs to I plus j, this implies I intersection j equals to I j, and theta is surjective as again belongs to I plus j. Therefore, by first isomorphism theorem, by the first isomorphism theorem, R mod kernel theta image, that is R mod ij R mod I cross R mod j. Now we can extend it to this extension. Of CRT. Let I1 IR be ideals such that 1 belongs to II plus Ij, 1 less than equals to I less than j less than equals to R. Then R mod I1 I2 IR product of ideas isomorphic to R mod I1 cross R mod I2 cross R mod IR. Okay. We proceed with induction proof. We proceed by induction. On R. If R equals to 1 trivial, R equals to 2 previous case, r equals to 1 it is enough, but r equals to 2 it is previous case. Okay, let I equals to I1 r minus 1 and j equals to IR. Now 1 belongs to IL plus IR, 1 less equals to L less than equals to R minus 1. This implies 1 equals to X L plus Y L, where XL belongs to IL and YL belongs to IR. 1 less equals to L less equals to R minus 1. Therefore, we can write as 1 minus XL product 1 to R minus 1 equals to Y1 Y R minus 1 that belongs to IR. Now what is this? This implies 1 minus X R minus 1 x1 x2 dot dot minus 1 to the power L x1 belongs to IR. Now this belongs to I, that is equals to J, right? Now summation x1 xr minus 1 belongs to I plus, okay, that belongs to where? This product, can you say that where? So here is small mistake. I should write here, not this way, sorry, I should write this way. So take this way, XL equals to YL minus XL equals to 1 minus YL. Now product it 1 minus YL. Now product XL L equals to 1 to R minus 1, product 1 minus YL L equals to 1 to R minus 1, that is equals to 1 minus Y1 YR Y1 Y2 minus 1 to the power L Y1 L minus 1 R minus 1, sorry, that is R minus 1. That is also R minus 1. I should write this YR minus 1. That is, now product belongs to XL L equals to 1 to R minus 1, that belongs to this product I, as xl belongs to il. 1 less equals to I less equals to r minus 1. And y1 plus yr minus 1, that is minus 1, belongs to ir, that is j, and so on. This implies 1 belongs to I plus j. This is here belongs to I, and this co-fellow from this to this belongs to j. So by previous theorem, Chinese remainder theorem, by previous theorem, we have 1 r mod ij equals isomorphic to r mod I cross r mod j. That means r mod, what is your I? 1 to r minus 1, and j is your IR. So I1 IR minus 1 IR isomorphic to and again by induction hypothesis by the induction hypothesis we have R mod isomorphic to therefore and we are done. Next, let V be a vector space. Application. Number 1, let R be a ring and alpha belongs to R. Then Rx mod x minus alpha isomorphic to R. That is not application. I should write application after this. This is observation. After this, the application. This is observation. I should write. So, what is this? Consider fx goes to f alpha. Check that ring homomorphism. What is kernel? Claim
Ideal generated by x minus alpha.
right. So it is a theta of x minus alpha is what is 0. This implies ideal generated by x minus alpha is subset of kernel. Then let fx converse but belongs to kernel since x minus alpha is monic. Monic means leading degree leading coefficient is 1. Coefficient of leading term is 1. uh, Monic, so we can divide it. Fx equals to x minus alpha gx plus, this is degree 1, so this is constant, that means degree 0, degree 0, some uh, I should write c where c belongs to R. So what is f alpha? That is 0 equals to c. This implies why f alpha 0? Because fx belongs to kernel. That means fx equals to x minus alpha into gx. This implies fx belongs to x minus alpha generated ideal. Therefore, x rx therefore kernel theta alpha x minus alpha generated ideal. Now theta alpha is surjective. As any pick any element beta belongs to R. So what is codomain? Codomain is R. So any beta belongs to R. Consider the polynomial theta x minus alpha plus beta. What is this? Alpha minus alpha plus beta equals to beta. So this is your preimage. Therefore, is surjective by the first isomorphism theorem. First isomorphism theorem we have Rx quotient x minus alpha generated ideal is isomorphic to R. Now for any alpha belongs to that this element. Okay, and what is your isomorphism? Fs goes to f alpha. Now application of CRT. Chinese remainder theorem.
Sir, this result is true for any irreducible polynomial?
No,
Oh, for only monic polynomial.
only for linear.
Oh yeah, linear polynomial. Sorry,
Linear polynomial with monic.
monic coefficient.
You
মানে one
cannot
coefficient.
say zx quotient 2x minus 1 isomorphic to z. This is not monic.
Okay.
uh, R be the real field. Let R, you know that this R is real field. I am not writing this. I just write Rx. This is field of real number. Quotient x square plus 1 isomorphic to C. Number 2, what is Cx quotient x square plus 1? What is this?
C.
That is essentially C cross C. So here I will apply Chinese remainder, but here not. So at first we do problem number 1 by simple way, no Chinese remainder, but although I write here application, so see it. Rx to C, fx goes to what should be the map? Fi. Okay, check that it is a theta is a ring horse. Now again we will compute uh, kernel theta and we will show that theta is surjective. Okay, claim kernel theta is isomorphic to x square plus 1 generated ideal. Again x square, this is monic polynomial. You know that theta of x square plus 1 is 0. So x square plus 1 generated ideal is subset of kernel theta. It is okay, trivial. Now let fx belongs to kernel theta. Write fx as x square plus 1 into gx. What should be the remainder? This is second degree, so linear polynomial should be the remainder, where a b belongs to r. It may be 0 both, then it is 0 remainder. Okay, apply theta both side. You know that theta is ring homomorphism, so this implies fi equals to 0, right, on both sides. What is this fi? That is 0 equals to I square. I should write one line more. Fi I square plus 1 gi plus ai plus b. The fi 0, I square plus 1 gi 0, ai plus b. That means a equals to b equals to 0. Hence, what is this? AB 0, that is fx equals to x square plus 1 gx. This implies fx belongs to kernel theta. Fx belongs to x square plus 1 generated ideal. So kernel theta is exactly x square plus 1. Now what is if you take, let C plus I D belongs to C, then f x minus I plus C plus I D, what is this? Not f, sorry, theta, I should write theta. So this implies theta is surjective, hence Rx quotient x square plus 1 generated ideal is isomorphic to C as ring, because all are ring isomorphism, not as the vector space only, as a ring. Now go to here. In Cx you can factorize this x square plus 1, you can write it as x minus I. You cannot factorize here Rx, but you can factorize here x minus I in where Cx. So write 1 as 1 by 2I x minus, I think it is plus, x plus, I should write plus,
Sir, I think some plus I.
huh? Oh, that is x plus I, x minus I should write this way, x plus I minus x, right? Okay, so
Hmm.
1 belongs to x plus y x plus I generated ideal plus x minus I generated ideal. These are co-maximal. By CRT, Cx quotient x square plus 1, this is product isomorphic to Cx x plus I cross Cx x minus I generated. Now look at the first observation. Rx quotient, R is any ring, Rx quotient x minus alpha isomorphic to R. So that is your isomorphic to C, that is isomorphic to C. Okay. As ring. Next question is, question, problem, Rx, R is field of real number, quotient x cube minus x isomorphic to what? Can you say?
R to the power 3. R cross R.
Right. R cross R cross R. Now, if and find, take any pair 1 2 3, yeah, 2 3 5, whatever. Find image, find fx belongs to Rx of degree 2 such that fx x cube minus x image of in is you take any pair, I think 1 2 3. Okay, this is problem. Now apply Chinese remainder theorem. Proof. uh, x cube minus x is x square minus 1, that is x plus 1 x minus 1. So one can write as x plus 1 minus x. So this implies 1 belongs to x generated ideal plus x plus 1 generated ideal. Again one can write as x minus 1. 1 belongs to x generated ideal, x minus 1 generated ideal, and one can write as half x plus 1 minus x minus 1 1. So there are pairwise co-maximal. By the CRT Rx quotient x cube minus x. I should write here this isomorphism is theta via Rx quotient x cross Rx quotient x minus 1. I should write plus 1 after that minus 1. No matter. And that is isomorphic to R, that is isomorphic to again R, that is isomorphic to again R. Now what is the isomorphism? Rx quotient x, f goes to f0, right? Note that Rx to R, what is the isomorphism? Quotient x, what is the isomorphism? Fx goes to f0. So 1 means, so if we write here 1 means those polynomial after dividing x leaves remainder 1. Here those if we write 2 here, those polynomial in Rx after dividing x plus 1 leaves remainder 2 again. And if we write 3, so those polynomial after dividing x minus 1 it leaves remainder 3, right? So these are the image. So can you construct a polynomial here fx of 2 degree So can you construct a polynomial? So what is remainder? If I write, if I divide x minus alpha, what is remainder? F alpha, right? F alpha is remainder. So can we find a polynomial of degree 2 Rx with f0 equals to 1, f minus 1 equals to 2, f1 equals to 3? Can you find it?
By Lagrange interpolation method.
You can find it by Lagrange interpolation, otherwise you can uh, go to this method.
I think the polynomial is 3
This
by
is
2 x square minus 1 by 2 x plus 1.
no, this is systematic way. What is the systematic way? I am showing you this fellow. Z equals to ay plus bx. Write 1 as ax plus x plus y, 1 as x plus y. From here I have what is okay. Write 1 as this fellow. Then if you want to find image of ai plus bj, a plus I, sorry, a plus I and b plus j, you should take a y plus bx. Now you can find it by your Lagrange interpolation method or by this method. That is your choice.
Actually, at first I consider alpha x square plus beta x plus 1, the polynomial fx. Then I solve
Okay,
alpha
okay,
and beta.
okay, okay. Let me write uh, alpha ax square. I should write. Okay, ax square plus bx plus 1, let fx. So f1 is what? Minus 1 equals to 2. That means a minus b plus 1 equals to 2. And f1 is your 3, that is a plus 1 equals to 3. So a minus b equals to 1, b equals to 2. What is ab? What is ab?
A is 3 by 2
b is
minus 1 by 2.
minus 1 by 2 or
Yeah,
1 by
1 by 2,
2.
1 by 2, minus 1 by 2.
So this is your
Yes,
fx.
this is a minus 1 by 2.
So what is a plus b is your 2, right?
B is equals to minus 1 by 2.
So a plus b is your 2, right?
Oh, yes. Oh, right. Sorry, I made a mistake.
3 by 2 x square plus half x plus 1 and theta fx plus x cube minus x equals to 1 2 3. That is next observation is let V be a vector space. Let vector and T V to V be a linear transformation. Let vector space over the field, I should write over the field K, over the field K and real linear transformation. Then for any polynomial gx kx gtv sorry gtv equals to g of t of v such that v belongs to v is a subspace. Okay. Moreover, if gx equals to p1 to the power p1x to the power alpha 1 p r x to the power alpha r be product of be the product of irreducible. Why the? Because it is also a unique factorization domain. I will discuss it later. Product of irreducibles then V quotient GTV, that is capital V. The quotient space is isomorphic to V quotient P1 alpha 1 TV cross 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 V quotient PR alpha R T V. Okay, that is cross, or you should write a direct sum. You know is that is direct sum. I should write direct sum. All of you know what is direct sum of vector spaces? Hello.
The sum, yes, the sum made of
Yes.
subspace and intersection. There is only zero element in the intersection.
No, that is for 2. V direct sum W. But if I write W1 direct sum WR, then what happened?
Then wi intersection wj only content only zero, zero only content in this intersection for any
No, no, no,
I
no,
and
no, no. That is, every element alpha belongs to this. It can be written as uniquely alpha 1 plus alpha r. And if we write w1 uh, plus w j minus 1 intersection wj is 0 for all j 1 to r. Okay, this is the condition. So these are all equivalent. So this is easy to think that in normal sum we can write alpha as just alpha 1 plus alpha r such that alpha I belongs to wi. This, and in direct sum this can be written as uniquely way. That is, if you have two representation such alpha equals to alpha 1 plus alpha r equals to beta 1 plus beta 2 plus beta r, then alpha equals to beta I. In direct sum this is unique expression. Okay.
okay. Sir, may I have a question?
Yes.
মানে বলছি যে এই ডাইরেকশনের যে ডেফিনেশনটা আমি দিলাম যে ডাব্লিউ ওয়ান থেকে ডাব্লিউ সামেশন ডাব্লিউ জে মাইনাস ওয়ান ইন্টারসেকশন ডাব্লিউ জে, তো মানে এই এই ডেফিনেশনটা তৈরি করার পেছনের মোটিভেশনটা কিরকম?
প্রত্যেকটাকে ইউনিকলি লেখা যাবে ওটাই। দুটোর জন্য কি করতে পারি আমি, w1 ডিরেকশন w2 ইন্টারসেকশনটা এমটি, তাই না? তাহলে আলফাকে তো প্রথমে লিখতে হবে আলফা 1 প্লাস আলফা 2, ঠিক আছে? এবার এটাকে যদি আরেকভাবে লিখতে পারি ইকুয়ালস টু বিটা 1 প্লাস বিটা 2, এখানে কি হচ্ছে আলফা 1 মাইনাস বিটা 1 ইকুয়ালস টু আলফা 2 মাইনাস বিটা 2, এইটা w2 তে আছে, এটা w1 এ আছে, আবার ইকুয়াল, তার মানে ইন্টারসেকশনে আছে, ঠিক আছে?
হুম,
তাহলে ইন্টারসেকশনটা জিরো মানে এগুলো ইন্ডিভিজুয়াল জিরো, এটা বলতে হচ্ছে। এবার আমি যদি এখানে 12 সংখ্যা বাড়াই তাহলে তো আর এইরকম ইকুয়ালিটিটা পাবো না, ঠিক আছে?
আচ্ছা।
তখন আমাকে বলতে হবে যে এই কন্ডিশন দিয়ে বলতে হবে w1 প্লাস wj মাইনাস 1 ইন্টারসেকশন wj ইকুয়ালস টু এইটার সাথে আর একটু মোর দ্যান দ্যাট। Now j for all j equals to 2 to that is r, যতগুলো ডিফাইন করতে হয়েছে। ওকে, so this is also a Chinese remainder theorem. So I put it as homework, but what should be the v quotient p1 alpha 1 t v, direct sum, what should be the map? Alpha goes to alpha plus this alpha plus this should be the map. Now compute your kernel, and same way you should write what is or you can do it by you can do it by two variable only, sorry, two ideal only, then then by similar way as induction for R variable. So this is your isomorphism. Take it as homework. I will discuss it in next class. So this theorem is only responsible, Chinese remainder theorem is only responsible for primary decomposition theorem, and if you take this irreducible product as linear, such as x minus alpha 1 to the power x minus c1 to the power alpha 1, that dot x minus cr to the power alpha r, this type of product, then you will find Jordan canonical form. So this is exactly some playing of Chinese remainder theorem. So why I am putting this as homework, I am expecting that you should learn what is direct sum properly and CRT properly. Okay, so next day I will discuss it. Now another exercise, just can you say that what is the kernel of the theta? Consider I should just write next day. We will discuss it. Learn direct sum. What is direct sum of subspaces? Just definition is enough. Okay. Uh, just one example. If I take k x y z to kt, x goes to t, y goes to t square, z goes to t cube. What is kernel theta? Can you say something? What is the meaning of this? If you take any polynomial f x y z, like as x cube y plus y square z plus z cube, something 5x square, whatever, put x equals to t, y equals to t square, and z equals to t cube. This is just polynomial algebra homeworks. Okay, put x equals to t, y equals to t square, and z equals to t cube. Check that this is a homomorphism. Okay, ring homomorphism. Now what is kernel? Can you say what is kernel?
यहाँ पे केटी का जीरो कौन होगा? ये तो जो लोग केटी के जीरो पे जाएंगे वो कर्नल होगा.
What is this? Say
केटी का जीरो यहाँ पे देखता कैसा?
what is? My claim is, see, see y minus x square, that is 0, right? Theta of y minus x square is 0, because what is this? What is y? Y is t square. What is x? X is t, right? This type. So y minus x square and what is happening here? And z minus x cube. Okay. How to prove? Clearly. And what is the meaning? Meaning is uh, y minus x square gx yz plus z minus x cube. What is the meaning of this ideal? This is the meaning of I should write g1 ax yz such that g2 belongs to kx yz, right? This is the ideal. So it is easy to see that y minus theta y minus x square is 0, theta z minus x cube is 0, because from definition of theta, so this is subset of kernel theta. Z minus x cube generated ideal is subset of theta. Now conversely, um, take f x y z belongs to kernel theta. Now divide f x y z by z minus x cube. A subset of, I should write k x y, this I should write, this is rz, this polynomial ring where r is your kxy. Note that kxyz is rz. So you are thinking that this is polynomial of z and ring is your kxy. Okay. So it is monic in z and degree 1 in z. So when I divide by z minus x cube, so it should be constant in z. So no z term. Constant in z. What is constant? Constant means from r. What is the noise? Right? Again, pxy can be written as similarly y minus x cube. uh, I write I should write g1 g2. Now no y term because I am dividing by y minus x cube, so rx. Think kxy as equals to ry means kx, this is your coefficient and this is your ring. So all are monic, so I can divide. If it is not monic, then I cannot divide. So then I have to go field of fraction. There is another technique, but here are all monic in z, monic in y, so I can divide. Z, it is your z minus x cube g1 rx. Apply theta. Now f belongs to kernel, so if we apply theta, this is 0. Now this is 0, this is 0, so rt, because x goes to t. Now rt is 0 means rx also 0. If rx equals to a0 plus a1 x square plus a n t x to the power n, this implies 0 equals to rt equals to a0 plus n t to the power n. This implies a0 equals to a1 and all are 0. This implies all are zeros. So this implies rt is rx also 0. So fxy z minus x cube g1 x y z y minus x cube, sorry, that is y minus x square, I think, y minus x square y minus x square, otherwise it will not 0, right? When you are applying theta, it will not 0. Y minus x square g2xy, and that belongs to z minus x cube y minus x square generated radius. So kernel theta is z minus x cube y minus x square. Now if I say x goes to t square, y goes to t cube, z goes to t5, 2 3 4 2 3 5, okay, t square, z goes to x goes to t square, y goes to t cube, z goes to t to the 5. And what is the kernel? Can you say? This is your homework, and I should stop here. K x y z to kt, x goes to t cube t square, y goes to t cube, z goes to t to the power 5. What is kernel? Can you say? Another question is, let alpha beta belongs to natural number. Kxy kt x goes to t to the power alpha, y goes to t to the power beta. What is kernel theta? You know that if alpha is 1, beta is 2, then if alpha is 1, beta is 2, then y minus x square, it is kernel, for example, and it is parabola. Now in general, what is kernel? Okay.
For the first uh, problem, it is z square minus x to the power 5 and y square minus x cube. I mean the generating polynomial.
That is your guess. Prove it.
Yeah, yeah,
Not
yeah. I'll,
okay. Prove it, because it is not so easy problem. You at first you try. Prove it. Okay.
okay, okay.
আচ্ছা, আমি আর একটা প্রসেস ট্রাই করছিলাম, যে এফ অফ এক্স ওয়াই জেড ইজ ইকালস টু সাপোজ হচ্ছে সামেশন এ আই জে কে এক্স টু দি পাওয়ার এল আই ওয়াই টু দি পাওয়ার এল জে জেড টু দি পাওয়ার এল কে। নাও আই এম অ্যাপ্লাইং থিটা অন এফ, তো বাই লিনিয়ার ট্রান্সফরমেশন বাই দ্য ডেফিনেশন অফ লিনিয়ার ট্রান্সফরমেশন থিটাকে
Some
ডিস্ট্রিবিউট করে ওটা ইজ ইকালস টু জিরো করে ওই অ্যাপ্রোচে কি কোনোভাবে কার্নালটা বের করা যাবে?
ও অ্যাপ্রোচে বের করতে গেলে খুব ধস্তাধস্তি হবে। যাই হোক, আমি এটা ট্রাই করছি যাতে সিস্টেমেটিক ওয়েতে বের করা যায়। ইট ইজ কারণ ক্যালকুলেশন এখন করতেই পারো, কিন্তু সেটা যদিও বা এই প্রবলেমে বের করতে পারো টেনে টুনে, অন্য জায়গায় পারবে না।
তাহলে
আমি
অন্য
যদি
যে মানে
এটাকে এক্স ওয়ান থেকে এক্সএন করে দিই আর ওখানে টি নিই, এবার এক্স আই গোস টু টি টু দি পাওয়ার কোনো নাম্বার দিতে থাকি, তখন কি হবে?
মানে তখন কি অ্যাপ্রোচটাই অ্যাপ্লাই করতে হবে যে কোন
আর
ট্রান্সফরমেশন?
এর পেছনে অনেক থিওরি আছে, তাই জন্য আমি এই পর্যন্ত এখন সিস্টেমেটিক ওয়েতে একটা দেখিয়েছি। আর আর এইগুলোকে হোমওয়ার্ক দিয়েছি, আগে ফিল করো যে কি ওইভাবে করে পারবে না, এই অ্যাপ্রোচটাকে আগে নকল করতে শুরু করো, যে এটা কীভাবে ডিভাইড করা হয়েছে। এবারে এখানে গিয়ে কিছুটা ধাক্কা খেতে পারো মেবি, 2-3 5-এ, তারপরে আরও জেনারেল অ্যাপ্রোচ করবো, বুঝেছো? আর সাম অফ মনোমিয়াল যদি তুমি লেখো, তারপর কিছুই এগোতে পারবে না, তোমার তো ডিভিশনটা দেখাতে হবে। তো অ্যালজেব্রা টেকনিক্যাল সাবজেক্ট, তোমার টেকনিক ইউজ করতে হবে।
স্যার আপনি একটা কোয়েশ্চেন জিজ্ঞেস করেছিলেন ওই কে এক্স ওয়াই জেড কোম্যাক্সিমালিটি কন্ডিশন, মানে ওইটা একটু ক্লিয়ার করে বলুন, আমি অ্যাপ্রোচটাও বুঝতে পারছি না ফার্স্ট ক্লাস মনে হয়।
তুমি
কোয়েশ্চেনটা একটু,
কোশ্চেনটা ছিল যে, কোশ্চেনটা বুঝেছো তো?
হ্যাঁ,
কোশ্চেনটা ছিল
ফাইন্ড দ্য কোম্যাক্সিমালিটি কন্ডিশন ফর
কোশ্চেনটা
আই
ছিল
জে।
আমি এখন কে এক্স ওয়াই জেড না করে পলিনোমিয়াল নিয়ে নিচ্ছি, এক্সএন আরও জেনারেল করে দিলাম, ঠিক আছে? আই জে আইডিয়াল, ঠিক আছে? আই
হুম
ইন্টারসেকশন জে ইকুয়ালস টু আই জে ইফ অ্যান্ড অনলি আই আর জে এর মধ্যে কোনো কন্ডিশন দিতে পারো।
হুম
ইফ অ্যান্ড অনলি আই আর জে এর মধ্যে কোনো কন্ডিশন,
আই যে আইডিয়াল অফ কে এক্স ওয়ান টু এক্স এন তো?
অবশ্যই আই জে আইডিয়াল অফ কে এক্স ওয়াই জে। তবে ওয়ার্নিং, দিস ইজ ভেরি টু মাচ হার্ড প্রবলেম,
ওকে
ঠিক আছে? তুমি ছোটোখাটো দুটো জায়গায় দুটো ভেরিয়েবলে ইয়ে করতে পারো, দেখতে পারো।
হুম
ওকে। আজকে রাখছি।